Today we're at journal page 28, scatter plots and trend lines. A scatter plot is a graph of points with one variable plotted along each axis. A correlation is a measure of the strength and direction of the relationship between two variables. You have positive correlation, negative correlation, and no correlation. One way to quantify the correlation of a data set is with the correlation coefficient denoted by R. The correlation coefficient varies from -1 to 1, with the sign of R corresponding to the type of positive or negative correlation. Strong negative correlation have R values close to -1. Strong positive correlation have R values close to 1. Weak correlations have R values close to 0. All right, let's take a look at the first example. All right, enter the value of R. Okay, so we're looking for R. And we're going to indicate whether R is closest to -1, -0.5, 0, 0.5, or 1 for the following data sets. So to do this, we're going to use our calculator. Okay, so we're going to go to On. You always want to go to On, New Document, No. Now in this case, we're going to go to number 4, Add List and Spreadsheets. We're going to do X, Y, and we're going to go fill in the table. Oh. All right, so now once you have the values typed in, you're going to go to C1, and then you're going to go to Menu, Statistics, Stat Test, Linear Regression T-Test. All right, this is X and Y. Press Enter twice. Now you're going to go down to the R value, and you're going to round to 2 decimal places. So R equals -0.81. Okay, which is closest to -0.5. All right, let's take a look at the next example. All right, so again, we're going to go to a calculator, and you want to go to On, New Document, No. We're going to go to number 4 again, Add List and Spreadsheets. So we're going to X, Y, and we're going to fill in the table. So all right. Now you can't use commas. All right, and then again, you're going to move to C1, and you're going to go to Menu, Statistics, Stat Test, Linear Regression T-Test, and then X and Y. And you're going to go down to the R value, which is 0.94. All right, which 0.94 is closest to 1. All right, let's take a look at the next example. All right, now in this one, we're going to turn the line of fit equation. Okay, so to do that, we're going to start the same way. So you're going to go On, New Document, No, Add List and Spreadsheets, X, Y, and then you're going to fill in the numbers. So All right, now this one's a little different in that you're going to go to Control Doc number 5. Control Doc number 5. You're going to do Tab X, Tab Y. You're going to do Menu, Analyze Graph, Regression, Show Linear, and you want the mx plus b. All right, we're going to move the equation so we can see it easier. And we're going to round to 1 decimal place. So our equation is y equals negative 0.8 x plus 12.4. All right. So our equation is negative 0.8x plus 12.4. And to find the correct graph, the key is the y-intercept 12.4. So we're looking for the graph that crosses at 12.4. So here, this looks like it crosses at 12.4, so we're good on A. But let's make sure none of the answers are correct. This is closer to 14, so it can't be B. Closer to 16, can't be C. Closer to 14, can't be D. So the answer is A. All right, let's take a look at the next example. All right, so again, we're going to find the line of fit equation. And so we're going to do the same process. So I'm going to go to On, New Document, No, number 4, Add List and Spreadsheets, X, Y, and then we're going to fill in the table. So all right. So now, again, we're going to go to Menu. Oh, I'm sorry. Control Doc. Control Doc number 5. Control Doc number 5. Tab X. Tab Y. Menu. Analyze. Regression. Show linear. We want mx plus b. And we're going to round our equation to 1 decimal place. So 7.9 x plus 49.4. All right. So we have our equation, y equals 7.9x plus 49.4. So we're going to find the one that crosses at 49.4. All right, so if you look at A, draw a line there. You can see it crosses at 49.4. So the answer is A. All right, so finish up example 4. Well, let's take a look at the next example. All right. Use a linear model to make a prediction and classify the prediction as an interpolation or an extrapolation. Okay, so they already give us the equation and they give us the x value. So we need to plug in the x value into the equation. So that's y equals negative 0.76 times 3.5 plus 7.7. Okay, so again, we can use our calculator. So I'm going to go to On, New Document, No, Add Calculator, and let's plug that in. So negative 0.7. So negative, the negative key is right here, negative 0.76 parentheses 3.5 plus 7.7. And you'll see it's 5.04. Okay, so for when y equals negative 0.76x plus 7.7 and x is 3.5, y is 5.04. Now, the prediction is interpolation because the prediction was made for a value within the extremes, minimum or maximum of the data set. All right, let's take a look at the next example. All right, so same thing here. We're given the equation, but in this case, we have a word problem. So let's look at the word problem. Raymond opens a car wash and keeps track of his weekly earnings as shown in the table. Use a linear model to make predictions and classify the prediction as interpolation or extrapolation. All right, so we have weeks after opening and weekly revenue dollars. So we have our equation. It says how much money might Raymond hope to earn in 9 weeks? Well, weeks, this is X and this is Y. So weeks is X. So that means X equals 9. Okay, so we're given the equation. We know X equals 9, so we're going to plug that in for X. So we have Y equals 570 times 9 plus 1010. So again, we'll use our calculator. So I can just go up and delete that one. And then we're going to do 570 parentheses 9 plus 1010. And we get 6,140. So that means Raymond might earn 6,140 after opening 9 weeks. The prediction is extrapolation because the prediction was made for a value outside of the extremes, minimum and maximum of the data set. All right, let's take a look at the next example. All right, last example. All right, identify the variables in each situation and determine whether it describes a positive or negative correlation. Complete the explanation to explain whether the correlation is a result of causation. Researchers at an auto insurance company are studying the ages of a policyholder and the number of accidents per 100 policyholders. The researchers compared each year of age from 16 to 65. After analyzing the data, the researchers found that as age increases, the number of accidents per 100 policyholders decreases. The variables are the age in years and the number of accidents per 100 policyholders. The greater age corresponds to a lower number of accidents per 100 policyholders, so there is a negative correlation. Causation is possible. It is possible that the age of the driver causes safer driving and therefore fewer accidents because of the experience of maturity. However, it is also possible that both the age group and the accident rate depend on another variable, such as likelihood of living in the city or likelihood of driving a car with anti-lock brakes or other advanced safety features. All right, that was the last example. Go ahead and finish it up and start working on your assignment and have a wonderful Wildcat day.